Hi, everyone. My name is Michelle Seebeck. I am the product marketing manager here at Progress Chef, and we're excited to introduce this latest webinar with our technical marketing manager, John Tonello. We're going to talk about containers, and we know that the guide for testing and the validating the containers, we want to make sure that everyone understands. We know that they use less computing space. They're faster and easier to deploy than traditional infrastructure, but we also want to introduce the interdependencies and complexities. And John's going to be able to take you through that journey. What we'll also be doing, as was mentioned earlier, feel free to pop into the chat or the Q&A a question, and we'll be able to handle it at the end of the call. And then I'll turn it over to John.
Thank you, Michelle. Hi, everybody. I'm John Tonello. As Michelle said, I'm part of the chef team here. In this relatively short webinar, 30 minutes, we're going to talk about not just testing Docker containers, but Docker images and hosts as well. And we'll go through each of those steps, including a demonstration of each of these. So this is our agenda. An introduction to Chef InSpec. And if you've never worked with it before or are new to the Chef ecosystem, we'll give you a relatively quick overview, a Docker refresher, and that isn't how to use Docker, but sort of how containers appear when we're doing scanning and those kinds of things as well. And of course, I'll do demo, and we're hoping to leave time for questions. We've got a great audience today and want to be able to get to anything that is of interest to you. If you missed the previous 3 webinars that we did in this series, they're all listed here. I'm not going to read them off for you. But if you go to our YouTube channel, getchef.com, all spelled out, those videos and recordings are available there. And they cover quite a bit of detail that complement and dovetail nicely into what we'll be talking about today, particularly with profile basics. And we'll talk a little bit about that coming up. So what is Chef InSpec? And it's an open source framework based on RSpec, but it's used for testing compliance and security, basically anything that you can think of related to your infrastructure and your applications. And it's important to note that there's no agent required. So all the activities that you do with InSpec and that I will show you, there are no agents required on the target nodes, which means you can target pretty much everything in your ecosystem across your fleet. InSpec at the most fundamental level compares the actual state of a system, whether it's a full VM, bare metal machine, cloud instance, or Docker container, against the desired state that you've defined and expressed in your Chef code. It's important to note that these examples today, you'll see some examples of specific Chef code. And though it's written in Ruby, you by no means need to be a Ruby expert. I don't consider myself a Ruby expert. So that shouldn't put you off. One of the great things about InSpec is it finds and discovers those violations to policies that you set, you define them, you take whatever your company policies are, or security policies, or industry, you turn them into code. It shows you immediately and gives you feedback on that. The Chef InSpec DSL is platform agnostic. In fact, today I'm doing some tests on 2 different kinds of Linux. One's Debian based and one is basically RHEL based, but you can use these same tests on a wide variety of Linux platforms, Windows and Mac OS. Sorry about that. I have a hay fever season itch. So in looking at this is Chef compliance, where we're really starting at the acquire on the top right and going around the circle. So you're basically setting up your environment, you're defining your code, you're detecting. Once you get results from InSpec, then you would remediate with tools like Chef Infra, writing cookbooks and recipes, or using public or some proprietary content to fix those things, see reports on that, and repeat, which is the idea behind compliance. You're not just checking the status today, you're checking it today and at any point in the future that you want to track. So what's it used for? In infrastructure tests, again, business apps and infrastructure requirements are defined in code. And these might be like, well, on our web servers, we don't want port 80, we want port 443. We don't want to use a certain version of TLS. We want to make sure there's no root access via SSH to our nodes. We want to make sure our application configuration files look a certain way and behave a certain way. And these are shipped in cookbooks, and we've added compliance phase, which actually brings together infrastructure configuration and the profiles from InSpec and those tests into the same workflow. Security tests work the same way. I like to think about them as really, these are three distinct things. You're checking your infrastructure, sort of the underlying systems. You're checking security related kinds of content and configurations, and then compliance content based on, you know, whether it's an application or a specific geographic location for systems, whatever it happens to be. This also includes Test Kitchen, which I won't be describing in detail today, but Test Kitchen enables you to basically test all of your Chef content locally or using cloud instances to spin up and test. So you can actually check infrastructure security and compliance long before you push things into test or production modes. One of the great advantages of InSpec is it makes it very easy to collaborate. When we talk about shifting left, but the concept of we want people to be able to be thinking about security and compliance related stuff with their work as early as possible and make it as easy as possible for them to do that. People often hear about security and if you're a developer, you sort of say, that's not my problem, that's somebody else's. That's really not true anymore. So the idea of making it easy for developers and anybody within your teams to see, understand, and write and share this content is important. That enables scalability. You know, you don't have a lot of pieces all over the place, people doing different kinds of things. And of course, the continuous visibility, meaning, you know, if this code is shared in a private Git repo, everybody can see it there, but the visibility is across the organization and not just within some developer's laptop. The language itself, as I said before, Ruby is the underlying language of Chef InSpec language and Chef Infra DSL, but you don't need to know Ruby at an expert level or at all. In fact, if you're brand new to Chef and you start learning the Chef language, you're learning Ruby on the side. Certainly if you have Ruby skills, that's great, because Ruby is a true language where you can do conditionals. You can have essentially if-thens, you can do detection and add logic to your code, which we'll see in an example I have coming up. So a resource within InSpec, and there are nearly 500 resources, half of which target cloud providers like AWS, Azure, and GCP. And it's really, what is the thing on the system that you want to get information about? You can check for files, install packages, ports. There are a ton of resources that are built in, plus you can write your own custom resources, and you can even execute shell and PowerShell commands. It covers the gamut, and we'll see some examples of that. This is a simple example that I have at the bottom, which is, you know, describe package nginx it should be installed end. This is highly readable by pretty much anybody. And though it's Ruby, you can see that it's very easy to understand and to share. So this, we're going to be targeting Docker related stuff today, but it's important to note that InSpec can target anything that you have access to. So if something has an IP address and you have a credential to get to that node, you can use InSpec on it. And I regularly target cloud nodes in my lab. I have Raspberry Pis, I have VMs, I have things that have spun up with Terraform or Vagrant, I have LXCs, it doesn't matter. And I have all sorts of different kinds of systems, OSs. As long as you can get to it, you can scan it. And here I have some examples. There are specific commands that you can do to target those different platforms, and we have some native capability just to make it work. So as long as you have credentials, you can do it. And Docker is particularly easy because if you're running it locally, you can scan very quickly and easily, as we'll see. So easy to deploy is a key feature, and as I said, doesn't require an agent. Chef Workstation is the developer kit, which replaced Chef DK about 1.5 years ago. And Workstation comes with InSpec and all the other tools you need, so you can get started quickly with everything that you need. It's technology agnostic, which means, as I said, you can use this across different platforms, regardless of what you're using. And it's easy to scale. It fully integrates with Chef Automate, which is our dashboard that enables you to see hundreds of thousands, even millions of nodes and their states. I won't be going into that in any kind of specifics today, but you can find some YouTube videos and some of our past resources on that as well. These are the keys here. We're streamlining the audit process by making it consistent. We're really making it possible, not just for the people on the DevOps teams or security teams, but really anybody to easily generate reports about the status of systems and applications running on those systems. And, we're streamlining test-driven development as well by giving developers that actual ability to test their configurations against the policies that you want applied right in the work they're doing without any special tools. My Docker refresher here, as I mentioned before, Docker in any container, they run on a variety of platforms, but they're not aware of their own existence. And by that, I mean, like, you can't scan a container looking for information about its host system or even its image. It just knows it exists. And in the examples I'll show, we'll be looking at those different things, looking at the inside of a running container, the image that created that container or others, and the host itself. So those 3 different phases. Here, I'm just doing and I'll show you this, that I'm going to be using the Docker containers actual ID, and I just outputted this, and I'll show you this in a live environment in a second. But I have, just so you know, a CentOS and an Ubuntu system running here. I have a couple images as well. So everything you're used to in the Docker world, from the kinds of commands that you would do to see what's running, those translate into what we're about to show. So bear with me for a second while I stop sharing and share my my lab here. Make sure I have the right one. Okay, hopefully you can see that. Can you confirm, Michelle, that you can see screen?
I can confirm.
Okay.
Right now I see a white bar.
Okay.
Now skinny white bar.
Can you see the whole thing?
No.
Let me stop. And try it again. How about now?
Yes.
Okay. So let me get rid of this. So let me just give you a word about my environment. This is my home office lab, and I'm running the workstation on a Linux workstation. I'm sorry, I got the control bar is in my way. Can you still see it?
I can.
Just want to make sure that it's scaling properly. I'm just going to look away so I can do this. So I have a workstation installed on this workstation. I also have some demo nodes, and I have Docker itself running on this machine and on another machine, so I can show the some of the capabilities. Now, before I was showing, you know, what is actually running. These are my a couple of containers that are running an app called Cowsay, which is, it's an old app that actually puts a little, when you log in, will create a little balloon and tell you the IP address. It's just a simple application that I want to make sure that it works.
Yeah, John, you know what? Right now, I just see the visual gallery. I don't see anything except a black
Okay,
screen.
let me do this again. Sorry about that.
I saw the cow say, there we go.
Better. Okay.
The magic of webinars.
Right. So these are the containers that I have running. So each one of these are the IDs of the node. And I have, I'm just going to clear and show that Chef Workstation is the latest version, and you can see that I have InSpec there. So I'm going to do a Docker PS. I just want to see the IDs of these. And I have my Cowsay code. And this is an example of a very simple profile. I've given the control a name, the impact, meaning how important I think this is, title and description, and then specifically this action. I want to describe the Cowsay to make sure it's installed on the system. This other content over on the left is content related to the actual recipe that configures it. And you can see in here, you know, I have, if it's a RHEL-based platform, do something. If it's Debian-based, do something else. So what I'm going to do is, because I'm going to just do a tree so you can see those files that I have. And my profile is in the compliance folder there. So I'm just going to do a inspec exec and the path to my Cowsay profile. And I'm going to target, actually, I need the ID. So I'm going to do this compliance. It's got my profile file in it. I'm going to target my Docker container. And I'm just going to take this ID of the running container and run it against it. So this container has previously been configured. Of course, the demo gods aren't, I see. Not 2 colons, 1 colon. So this has been previously configured, and I want to hopefully see like, oh, okay, is it working or isn't it working? And it shows that it's Cowsay is not installed on this particular thing, and I can see the results. I can also, within this, if I have another cookbook, I can run those commands and the profiles against it. In this case, I can see specifically that this application is not installed in there. Now, one of the other things I can do is take some public benchmarks. And these, I don't have it on my machine at all, but it's available on GitHub, on DevSec repo. And I do the same thing. Oops. Let's see. This. And well, this does its thing. I'm just going to show you what this benchmark is. This is, there's a Docker benchmark similar to this that's, I'm just pulling the code directly from a GitHub repo live, and it's applying it. It's taking, it's interpreting, finding what it needs in that and running it. So it's running this baseline that has nearly 100 different controls in it against my running container, not the host, but the actual container itself. And the baseline is saying, hey, all these things in green are good, all the things in red are not, and I could then go and remediate that. So in my environment, I have my Docker images like this. And the next thing I'm going to show is really how to take a look at scanning Docker images themselves. And for that, I can create a profile that looks at the specific, sorry, I lost my screen. The specific content. Let me just open a different folder. Within my Chef repo, I have my profiles. Just so you can see what this profile looks like. Very simple, but it's an image. I want Ubuntu 2004 should exist. It should have these tags. It should be from this repo. This is to guarantee that I feel confident about the actual content that I'm building my containers from, that the image itself is correct. And I can take it and run this. I'm going to just move up into that folder so I can. This is the same that we were just looking at here. So now I'm going to do an InSpec exec using the Docker profile. And instead of targeting the container, I want to target my actual host, which is this, my Docker host, workstation, add my credential. This is going to run the profile, which is inspecting those factors about the image to make sure that they're good. So this isn't something that the container is aware of. It's purely on the host itself. You can see it's pretty easy to do that. And if I had multiple images, I could script repetition of that. The final thing I want to show is related to that initial content that I showed with this is a CIS Docker benchmark. Again, it's a publicly available GitHub repo. It has a number of controls in here that are specific to security, the daemon, runtime of the Docker host itself. And this stuff is going to be tested automatically by using, again, the remote like this. I'm doing github.com, devsec, and it's the CIS Docker benchmark. Oh, I think it's a benchmark. Sorry. Yep. Again, I'm going to target my actual host itself, which is Chef at Workstation. And I'm going to use my credential like this. And what is this is doing is going out and grabbing that remote profile. Oops. And of course, I didn't put in the proper path in my haste. It's going out, grabbing that profile, which is an extensive profile, and applying it to this particular Docker host. This has a lot of controls in it, and you can see there's 145 successful, 91 failures. Did that in real time on this host, and I can see in quite a bit of detail. So those are the basics. Sorry about that. And so that gives you a quick overview. I went a little longer than I wanted to, but hopefully it gave you some good insights into the 3 different kinds of areas to use InSpec on with containers: the container itself, analyzing the images, and analyzing the hosts. And with that, Michelle, do we have any questions?
Let me take a look. I know earlier Christopher had a question about the test-driven development and how you were saying that developers are engaged in the security and the compliance. Can you give a little bit more explanation on that? I think it was a couple slides back.
Sure. When we talk about having shifting left, the profiles can be shared among teams, and these are profiles that can be testing configurations and can be testing security, so that they can write these or use existing company profiles and include them right in their recipes and cookbooks and what they're doing. We have what's called compliance phase now, which enables developers anywhere in the Chef ecosystem is to not only identify the infrastructure configurations, but also the InSpec profiles at the same time. So when a machine is running and the Chef client runs, in those cases, it's not only applying the code to configure the node, but it's also automatically reporting the information back. And that capability is in the hands of developers.
Okay, thanks. Is that good? Yeah, I think that answered it. Yep. Any other questions? Oh, can I run InSpec against OpenShift? If so, is the module open source?
InSpec is not what we would consider open source. If you have an IP and you have a credential to access that, because InSpec, in my examples, I was using my SSH key. You could also use WinRM, you do things like that. If it has an IP and it's reachable by your workstation, you can scan it. Now, workstation itself is open source and freely available. And you can, since you don't need to install anything anywhere else, you can run it and target any node that you have, if it's addressable.
Okay.
And actually, there's some socket capabilities as well, but it's primarily through API accessed by network address.
Marilla, does that help you? Let me take a look. Yes, fantastic. Any other questions? I know that we are running at time, so I don't want to take any more of your undue time, but I definitely want to go ahead and make sure that all the questions are answered. In that chat, I have dropped in a couple of links. I have our DevRel live streams. I also have in there the great resource that we have for Chef Learn and our docs, so that you can go ahead and just click on it and get right into our documentation and learn more. And I don't see any other questions at this time, John.
Great. And there's I did a blog post that's available on chef.io called Chef 101 Guide to Best Practices, which actually, if you're brand new to Chef, will take you from very beginning all the way through stages like this. Though it's not container specific, it gets into combining cookbooks, recipes, InSpec profiles, and also includes information about InfraServer and Automate, the dashboard, and the storage components on sharing content that's available on our Chef.io blogs website.
Oh, and I've included a link for your viewing as well.
Thank you.
And if anybody wants a copy of today's presentation and doesn't want to wait the 72 hours, please drop me a note. Again, I'm the marketing manager here, the product marketing manager here at Progress Chef, and it's just michelle.seebeck@progress.com.
Great. And with that, I guess we're ready to wrap it up. Thank you for attending.
Thanks, everyone. Have a great afternoon.